Hello everyone and welcome to the Advanced Numbers lecture. So in this lecture we're going to go over a few more representations of numbers in Python and then a few of the built-in methods that have to do with numbers in Python. It should be a pretty brief lecture but an interesting one. So just going through the Jupyter Notebook, we're going to look at hexadecimal representation of numbers, binary representation numbers, and then a couple of built-in arguments, or excuse me, functions for numbers. So in case you're not familiar with hexadecimal formatting or binary formatting, I went ahead and linked the Wikipedia pages for both those formats, and you can check them out as far as the descriptions and how they actually work here. So I won't be teaching you what hexadecimal numbers actually are, what binary numbers actually are. You can go ahead and read about that on the Wikipedia page yourself. So I figure these two topics are only useful if you're familiar with the computer science topics or in your math classes and we're curious on how to do it in Python. So quick overview on how to do them in Python. For hexadecimal numbers, you can call the HEX built-in function, and it will convert numbers into the hexadecimal representation of numbers. So for instance, if I call 12 there, it returns the hexadecimal representation of that number. And let's just do another one, such as 512, and there's another representation of it. If you're interested in binary representation of numbers, you can use the bin function, and that will return the binary representation of some numbers. So for instance, if we just go for some classics, such as 128 or 512, you can see those are the binary representations of those numbers if you're familiar with binary representation. Okay, now let's go over some more common built-in functions. So we know that we can call to the power using 2 asterisks, but there's also a function for that. So you can call POW, and it will do the same thing. If you put in 3 arguments, such as this, what will happen is the third argument will be treated as a mod. So with 2 arguments, it's the equivalent of x to the power of y. X and y are your first and second respectively. But with 3 arguments, it's equivalent to x to the power of y mod z. And this just has to do with some efficiency cases, in case you're interested in why there's a whole built-in function for that. Now, there's also an absolute value function, which is ABS, which will return the absolute value of a number that you put into it. There's also the round function, and it will round the number to a given precision in decimal points. And by default, it's 0. So if I wanted to round, let's say 3.1, it would round it off to 0 decimal points. So for instance, to make it clear, if I also put in just 3, it rounds it off to 0 decimal points. Or if I put in 3.9, it rounds it off to 0 decimal points here to just 4. Okay, interesting to note though, it always returns a floating point number, which is why you're seeing that 0.0 there. You can also specify how many digits you want after the decimal point. So for instance, if you had the longer representation of pi, let's say you only wanted to see 2 decimal places past the points, you can add that in as a second argument. Okay, that's really all there is for the advanced numbers. Should have been a pretty brief and straightforward topic. Main takeaways are there's the hex and bin functions for you in case you're interested in that. There's also these built-in functions, abs and round, and also pow for power. And Python also has a built-in math library, which may be useful to play around in case you're ever in need of some more mathematical operations. Okay, and as always, here's the Jupyter Notebook that goes along with this lecture for you to check out. All right, thanks everyone. I'll see you at the next lecture. Hello everyone, and welcome to the Advanced Strings lecture. So string objects have a variety of methods we can use to save time and add functionality. And what we're going to do is explore some of them in this lecture. So let's go ahead and create a string called hello world. And let's explore some different methods we can use. So let's start with changing case. So we can change cases to upper and lower case, and there's a couple methods we can use. One of them is the capitalize method, and what the capitalize method does is it capitalizes the first word in a string. We can also use the upper method, which you may have seen before, to uppercase every letter in a string, and then we can also use the lower to lowercase every letter in a string. There's also location and counting methods. So if I wanted to, for instance, count how many O's there are in a string, I can use the count method, and I can also find them. So I can say find the first occurrence of an O, and it'll return the index where that happens. There's also formatting methods, and these are a little strange, and they're also not used that often, but it still might be good to know them in case you ever run into them. First one we're going to talk about is the center method. So let's go ahead and check our string. It's still just hello world since we lowercased it again. And what the center method does is it allows you to place your string centered between a provided string with a certain length. So these are pretty esoteric, and I've actually never seen this used in code, but it's still a method you can use. So for instance, let's say you wanted to center your string hello world between a bunch of z's, and you wanted the total length of that string to be 20. Then this is what it would look like. So we centered hello world between z's, and the total length of the string is 20. Okay, there may not be too many use cases for that, and I've personally actually have never used it. This method that you may or may not use is the expand tabs method. So for instance, if I say hello t, and that will break it to a tab. Whoops. Let me make sure this is working. So this backslash t, when you print it, it will be an escape character for a tab. So it'll actually read hello tab hi. So this is going to be useful if you ever find yourself parsing through a lot of text data. And instead of having to print it, what you can actually do is just call the expand tabs method, and it will do the same thing. Again, not used that often. Let's go ahead and check out some other methods that check if the string is some sort of case. So for instance, I'm going to set a string just called hello. And there's a method called isAlnum, and this checks if all the characters in S are alphanumeric. And in this case, it's true. And what we can also do is just check if they're all alphabetic. So numeric doesn't count anymore. So we can just check is alpha, and that's also true. These are actually quite useful, and I have seen them used a lot, especially if you find yourself doing some sort of natural language processing techniques. Another couple of ways, or a couple methods we can use is lower, and this will return true if all case characters in S are lowercase, and if there's at least one case character in S. We can also check is space, and it will return true if all characters in S are white space. In this case, that's not the case, so it should return false. So is space, which will return true if all characters in S are white space. It's false since we have letters in there. Another method called is title. So we can check is title, and what that does, it'll only return true if S is a title case string, and there's at least one character in S. So uppercase characters may only follow uncased characters, and lowercase characters only follow cased ones. Another method is upper, and that will return true if all cased characters in S are uppercase. So is upper, this case it's false, but if I were to say, let's say hello, all uppercase, and then I asked is upper on that, then that is true. All right. One last method for checking cases is ends with. So I could check s.ends with, and let's say I wanted to verify that it ends with O. Yeah, and this is basically the same thing as just doing this, right? Checking if that last character in the string is equal to something, and it returns a Boolean. Okay, so now we're going to move on to some built-in regular expression operations. So strings have some built-in methods that can resemble full-on regular expressions operations, and one of them that's really commonly used is split. And we can use split to split the string at a certain element and return a list of the results. So let's check our string, which is hello, and let's say we wanted to split the string at E. Then split will return the result in a list, so everything before that E, and then everything after it. And remember, it only separates at the first occurrence. Excuse me, it'll actually separate at every occurrence of E. So just to make that clear, I'll show you an example. So if I have a string that's looks something like this, I could say split at I, and it'll split it up at every instance of that I. Okay, there's also partition, which is pretty similar to split, but in this case, what partition does is it'll have the head, the sep, and the tail. So what it'll do is it will search for the separator, whichever you feed it in the argument, in S, that string, and return the part before it, the separator itself, and the part after it. And if the separator is not found, it returns S and 2 empty strings. So for instance, if I said partition of I here, this one is at the first instance of I, or whatever separator you put in. So it'll give you the first part, the separator, and then everything else that happened after it. So unlike split, which splits at every instance, partition will only do it at the first instance, and it will also return the separator in the middle. So the front, separator, and the back. Okay, so that's it as far as the lecture and strings. Let's just go ahead and do a quick review. A lot of these were Boolean checks, so I know that was kind of hard to keep track of. It's probably better just to read along in Jupyter notebooks. But we went over methods for changing case, such as capitalize upper and lower. We looked at location and counting, such as count and find. We looked at a few esoteric formatting ones, such as center, also expand tabs. And then is check methods, so all the tons of methods to check if the string is in some case, such as is alnum, is alpha, is lower, is space, is title, is upper, and ends with. And then we looked at some built-in regular expressions, such as split and partition. Okay, so you should feel comfortable using the variety of methods that are built into string objects, and you should definitely feel comfortable if you run into them when you're reading someone else's code. All right, that's it for the Advanced Strings lecture. Thanks, I'll see you at the next one. Hello everyone, and welcome to the Advanced Sets lecture. So in this lecture, we'll be learning about lots of different methods for sets that you may not have seen yet. And we'll start by going over the basic ones you already know and then dive a little deeper. So as always, there's a Jupyter notebook that has everything we're going to go over as well as many examples, so you can go ahead and check that out. So let's go ahead and look at advanced sets first. So in this lecture, we'll start with some of the basics. So we'll start with building our set, and then how do we add things to a set? Well, we just use the add method. So here I'm going to add 1 to my set, and I'll add 2. And remember, a set won't take any duplicate items. It only presents them 1. That's what makes it a set. So if I were to try to add 2 again, I only get 1, 2. So we know we can add with add. So we can also clear or remove all the elements from the set using the clear method. And that looks like this. So if I check my set, now it's empty. So another interesting method that you may not have seen yet is copy, which returns a copy of the set. So to show you that example, here I have set 1, 2, 3, and I'm going to set a variable called sc to a copy of that. And now sc is 1, 2, 3. So note, it is a copy, so changes to the original won't affect the copy. So if I say s.add, here is my original, there's the copy. Okay, so what about a couple of more methods that you haven't seen yet, such as the difference method? So difference method is a super useful method, and it returns the difference of two or more sets. So the syntax looks like this. You provide your set, call difference, and then the set you want to check the difference between. So the only difference between S and SC is this 4 elements. So it returns the elements that are different. And so another really interesting related method is difference update. And what difference update does is the method returns set 1 after removing elements from set 2 if you have this sort of format here. So I just copied and pasted this from the Jupyter Notebook. So the syntax looks like this. You have set 1, you call for the difference underscore update with set 2, and the method returns set 1 after removing all the elements that were found in set 2. So I'll show you an example of what this looks like. I'll create a new set, S1, create another new set, S2. This will have 1, 4, 5. And now, if I call S1 difference updates with S2, and then I'm going to call S1 again. So note what I get back, 2, 3. So the matching elements between S1 and S2 was the 1 element here, number 1. And what difference update did was it returned the first set after removing all the elements found in the second one, in which case it would have been 1, so you get back 2, 3. Another interesting method is the discard method, and it removes an element from a set if it's a member. So if the element's not a member, it doesn't do anything. So I'll show you what I mean by that. So let's go ahead and check out this set. We have S, which is 1, 2, 3, 4, and I can discard. Let's say I discard the 2 elements. And if it's in the set, it'll get rid of it. If it's not in the set, say 12, nothing happens. So you don't get an error if it's not in the set. Something to keep in mind. Okay, now let's go ahead and learn about the intersection method, another very useful method for sets. What it does, it returns the intersection of 2 or more sets as a new set. And the intersection is just the elements that are common to all the sets. So let's go ahead and redefine S1 and S2. So 1, 2, 3, 4, and then S2 is going to be equal to 1, 2, 4. Okay, and what I'm going to do is check for the intersection of the 2. And there's an intersection update method, which we'll learn about in just a second. So S1 and S2, the elements that are common to both of the sets is 1 and 2. All right, so intersection update will update a set with the intersection of itself and another. So if I try this method on S1, notice S1 is 1, 2, 3, but if I say S1 intersection update with S2, it will actually update set 1 to be equal to the intersection of set 1 of S2. So S1 was 1, 2, 3, and now it's going to be with intersection update equal to, that intersection. So now if I check S1, it's 1, 2. So let me just break that down because I know it's a lot of 1s and 2s that I'm saying. So originally set 1 was the numbers 1, 2, 3, and set 2 was the numbers 1, 2, 4. So the intersection, or the elements that are in common between them, are the numbers 1 and 2. That's their intersection. And with intersection update, it basically makes the first set equal to that intersection. So if I check it again here after the update, I just get 1, 2 back. Okay, so now we're going to check a method called isThisJoint. So I'm going to create a few sets to show you how it works. So I'm going to create 3 sets, S1, which is 1, 2. I'll create S2, which is 1, 2, 4. And let's say S3 is equal to just 5. Okay, so this method was going to return true if the 2 sets have a null intersection. So for instance, S1 is disjoint S2 is going to return false. which makes sense because they do have an intersection. They have the elements number 1 and number 2 are in common between the first two sets. Now, for instance, S1 and S3 here don't have any things in common, so they don't have an intersection, which means they have a null intersection. So if I was to say S1 is disjoint with S3, I should get true because they do have a null intersection. Another interesting method is subset, and the method reports whether another set contains this set. So if we look at what S1 equals, it's 1, 2. If we look at what S2 equals, it's 1, 2, 4. So you notice S1 is a subset of S2. And we can check that by asking is subset with the is subset method, and this will return true. And then basically the reverse of that is superset. So the method reports whether the set contains another set. So I can reverse this and say is S2 is supersets of S1, and that's also true. So they're just the inverse of each other. All right, now we're going to learn about a method called symmetric difference, and there's also a symmetric update to go along with it. So symmetric difference will return the symmetric difference of two sets, and what that is, it's all the elements that are exactly in one of the sets. So you can think of this as basically the opposite of the intersection. So if we have S1, that's 1, 2, and we have S2, that's 1, 2, 4, then the elements that are only in one of the sets is that 4 element, right? So I can check for the symmetric difference, and that will return 4, since that's the element that's in exactly one of the sets. Okay, and then there's also a update to go along with that as well if you wanted to change S1 into just the symmetric difference, or 4. Moving along, I will now go over union. So the union method returns a union of two sets, and that's all elements that are in either set. And that will be here in this case 1, 2, 4, because 1, 2, and 4 are in either set. Okay, and last but not least, we'll go over the update method, and it updates a set with the union of itself and others. So that means if I said S1.update S2, if we check S1, it's now the exact same result as if we asked the union on itself and another one, S2. Okay, so you should have at least now a complete awareness of all the methods available to you for a set object type. I personally think the data structure is underutilized by beginners, so try to keep it in mind when you're trying to do comparisons or looking for unique values. The data structure itself is extremely useful, and let's just take a brief overview of everything we learned as far as methods. So we know about the add method, which adds elements to a set, the clear method, which removes all elements from a set, the copy method returns the copy of the set, the difference returns the difference of two or more sets, has that syntax. Remember, there's a lot of update methods which will change the first set in that method. The discard, which removes an element from a set if it's a member. If the element's not a member, it doesn't do anything, so it won't throw up an error. Intersection returns the intersection of two or more sets, which is just the elements that are in common to all of sets. Also has an update method. Is disjoint returns true if they have a null intersection, so they don't share any elements. Is subset reports whether another set contains that set. Is superset the inverse of that. Symmetric difference will return all elements that are in exactly only one of the sets, and then you can update it as well. Union returns a union of two sets, all elements that are in either set, and then update will update a set with the union of itself and whatever others you pass in as arguments. Okay, so that's it for the advanced sets lecture. Thank you and good job. I'll see you at the next lecture. Hello everyone, and welcome to the Advanced Dictionaries lecture. So unlike some of the other data structures we've worked with, a lot of the useful methods available to us in dictionaries have actually already been explored throughout this course. So we're just going to touch on a few more methods for dictionaries in this lecture, and also dictionary comprehensions. So let's go ahead and get started with the live code. As always, the Jupyter Notebook's available for you if you want to check it out as well. Let's start by creating a very simple dictionary. We'll just have two keys, K1 with a value of 1, and we'll also have K2 with a value of 2. Okay, so here's our dictionary D. And what we're going to do is use that later on, but that's just a reminder for the syntax of a dictionary. If you remember from the list comprehension lecture, we were able to construct lists using list comprehension. So just like list comprehensions, dictionary data types also support their own version of comprehension. It's not super common to use it as much as list comprehension, but let's go ahead and still learn the syntax for it. So we'll start with a pair of brackets, and then what you do is you define the key and then the value in the same colon notation you would for a normal dictionary. And then you write whatever conditions you want. So in this case, what I'm going to do is say, have the key be x and the value be x squared for x in range 0 up to 10. So if you notice, we've actually been able to create a dictionary through this dictionary comprehension. Another question that might come up is, what if you want to assign keys that are not based on the values? Well, you could use zip in a manner like so. So I could say zip, maybe pass in a list. Here I'll just write a short list so I don't have to write too much. And then zip it, let me close off that string, with a range. Let's just do a range of 2 here. And then we'll do tuple unpacking. So we'll say key value, value squared, key, and looks like I accidentally forgot parentheses there. And there you have it. So again, this really isn't as common as list comprehensions. List comprehensions you'll see all the time. Dictionary comprehensions, it becomes hard to read, especially if you're trying to assign key names that are not based off values. So it's good that you're aware of it, but I wouldn't have it be your go-to throughout your coding. But who knows, if it's called for and it makes sense, go for it. All right, so next up, we're just going to review iteration over keys, values, and items. So dictionaries can be iterated using their iter methods. If you're using Python 2, so I can say for k&d dot iter, and you have iter items, iter values, iter keys. So here we have our iter items. Let's just go ahead and see what that looks like. Prints, we'll say k. And notice iter items actually returns tuples of both the keys and the values. We can also do just the values. And there we have it. And we can also do just the keys. And there you have that. You can also use view methods to view the items, keys, and values. So if you're using Python 2, you can say, we can actually grab all this, delete it, and just say d dot view items. That's the function, so you have to close it off. And it'll show you this object that's a view items. And then we can also say view keys. And then you probably guessed already, you can say view values. And there you have that. So that's really all the other methods that are in dictionaries that we haven't covered or seen throughout this course. So I wouldn't say dictionary comprehensions are super common. And depending on which Python version you use, iteration over keys may be different for you. If you're using Python 3, you won't have to worry about the generation issues. And as far as view items, if you have a large dictionary, you're going to want to be careful calling this because you may just get a huge output. All right, well, that's it for the Advanced Dictionaries lecture. You should have been pretty familiar with some of these already. And we'll go ahead and stop the lecture here. As always, you can check out the Jupyter Notebook for some more examples. Okay, thank you everyone. I'll see you at the next lecture. Hello everyone, and welcome to the Advanced List lecture. So in this series of lectures, we're going to be diving a little deeper into all the methods available in a list. So these aren't officially advanced features, just methods that you wouldn't typically encounter without some additional exploring. So we've actually seen quite a few of these: append, count, extend, index, insert, pop, remove, reverse, sort. So we may have seen a lot of these already just by using lists and in the methods lecture itself, but let's go ahead and go over them just in case you need a refresher. Okay, so let's start by making a very simple list. I'll call it L, and I'll have 1, 2, 3 in it. You definitely should have used this method by now. It's append. Whoops. It's the append method, and of course, it just appends an item to your list. All right. So we discussed this also a number of times, the count method. So we can use the count method, and it'll count how many times an object occurs in your list. And it'll actually count whether it's in there or not. So notice how I counted 10, doesn't occur any times. 1 occurs once in my list. So moving along, here's one that you may not have heard of or may not have used yet. It's called extend. So many times people find the difference between extend and append to be unclear. So I'm going to show you by means of examples. So let's go ahead and make a list called X. It's just like Y, or just like the L list. It's going to have 1, 2, 3. I'm going to append another list to that. And this list will contain 4, 5. And I'm going to say print X. Okay, so what happened here? So remember, append just adds the entire element to the list. So what it's doing here is it's adding this and appending this list to an element in itself. Now, what happens if you wanted to extend this list into your original list? So that's where extend comes in. So now I'm going to show you again, but in this time we're going to use extend. So I'm going to say x dot extend and pass in a list again with just 2 elements, 4, 5. Then I'm going to say print x. So notice the difference here. You're actually adding in the entire list. So your extend will append each element in that iterable, and that's the key difference there. So again, just to cover, append is going to append elements, just the entire iterable, all the elements in it. And what extend does is append elements individually from the iterable. All right, so let's move along. Let's take a look at our L list. It has 1, 2, 3 in it, or 1, 2, 3, 4, excuse me. And index is another method that we've probably seen already. So what does index do? Index will return the index of whatever element is placed as an argument. So let's find the index of 2, and it's 1, right? Because indexing starts at 0, 0, 1. The object that the 1 index is 2. Something to note here is that you will get an error if you try to index something that's not in your list. And I'll tell you very clearly, value error 10 is not in list. All right, let's move along with insert. So what does insert do? Insert takes in 2 arguments. It takes in index and the object. So this method places the object at the index applied. So for example, let's just make sure we know what L looks like. L looks like 1, 2, 3, 4. And what I'm going to do is in that list, I'm going to insert at index 2 a string called inserted. So note the order here of the arguments. You put in the index first, and then the object you want to insert. So what does my list look like now? Notice how it has the inserted at the 2 index. So 0 index, 1 index, and at the 2 index, it's placed this string inserted here. So again, you put your index in first, and then the object you want to insert second. Okay, might be useful if throughout your code you really want to make sure that you know the particular index of an object. Okay, moving along, you've definitely already seen pop, which allows you to pop off the last element of a list. So again, here's the list, and I can pop. And by default, it's the last element in that list. So I set lpop equal to LE, and LE, notice it was 4. And again, remember that change is permanent. It's in place on your list. Okay. So something else to note is that you can pass in an index into pop. So I could say pop 0. Notice how it's 1. So now L looks like this, 2 inserted 3. So what's another method for a list that we can use? Remove is another method. So the remove method removes the first occurrence of a value. So for example, I have my list, and let's say I want to remove that string inserted. So I pass in the value, and it will now remove it in place. So I want to show you one more example with this, just to make sure you get the idea that it's only removing the first instance of it. So here you notice my list is 1, 2, 3, 4, 3. There's 2 3s in it. So if I say l.remove 3, it's only going to remove the first instance of it. So that's something to keep in mind with remove. Another method we can use, if I see L here, is reverse. And as you might guess, reverse just reverses your list and reverses the indexes for them. So note that this occurs in place, so it will affect your list permanently. And we can also use a sort method on our list, and sort will sort your list also in place. So those are all the methods on a list. Some of them we've covered a lot, some of them might be new to you, but just go ahead and again review the Jupyter Notebook, make sure you understand everything. So let's just go a quick rundown of everything we learned. So append, you've definitely used this method. It appends an element to the end of a list. Count, we've discussed this as well, but it'll count how many times that object takes place in your list. Whether or not it actually occurs in your list, it won't return an error. Extend, here's the tricky one. Remember, in extend appends each element in that iterable, so it appends here 4 and 5, not just the list with 4, 5. Index will return the index of whatever element's placed in as an argument, but remember, it has to actually be in the list, otherwise you get an error. Insert takes in 2 arguments, first the index and then the object. So here we inserted at 2, this word or string inserted, and notice now it's inserted in the index 2. Pop, we've seen that already, allows us to pop off the last element of a list, or we can also pass in a specific index if necessary. Remove, the remove method removes the first occurrence of a value, so we just saw an example of that. Reverse, as you know, reverses a list, and sort will sort your list in place. So both reverse and sort are in place and will affect your list permanently. Okay, that's it for the advanced lists lecture, which is basically just all the methods on a list, and some of them you wouldn't typically encounter without some additional exploring. Okay, thanks everyone, and I'll see you at the next lecture. Hey everyone, welcome to the Advanced Python Objects test. So this will actually be probably a pretty brief test, but an interesting one. As always, just go to the Advanced Python Objects test notebook. You can click the download link on the right and fill it in yourself. I'm just going to go over the problems quickly so there's no confusion. First problem that you're going to do is convert the number 1024 to binary and hexadecimal representation. Problem 2, I want you to round 5.232222 to 2 decimal places. That was a lot of 2's. Okay, next, moving on to the advanced strings. Here, I want you to check if every letter in the string S is lowercase, and use the methods you learned in this section of the course. Problem 4, what I want you to do is check how many times does the letter W show up in the string below. After that, advanced sets. Problem 5, I want you to find the elements in set 1 that are not in set 2. Then I want you to find all the elements that are in either set for problem 6. In advanced dictionaries, problem 7, I want you to create this dictionary right here. So note the pattern, what's going on, and then I want you to use dictionary comprehension to create that dictionary. Then advanced lists, just reverse and sort the lists below. Okay, that's it, and good luck. Honestly, if you're this far into the course, you may not even feel like you need to be tested. So if you feel that way, go ahead and feel free to skip this advanced Python objects test. But hopefully it should be pretty straightforward to you by this point in the course. Okay, thanks everyone. Hello everyone. In this lecture, we're going to go quickly through the solutions of the advanced Python objects test. Okay, so first one you had to do is use bin and hex functions in order to do those conversions. After that, you had to use the round function in order to round. Problem 3, I was expecting you to use the isLower method. And then similarly in problem 4, it was another method for a string, count, and then W. Advanced sets, the methods here were difference for problem 5 and union for problem 6. Advanced dictionaries, this one might have been tough if you didn't see the pattern. And also dictionary comprehension in general is a little strange, but this was the solution for the dictionary comprehension. It was just cubing all those numbers, and the key was the number, the value was the number cubed. Okay, advanced lists, hopefully these are pretty straightforward. Should have been just from the problem itself, reverse and sort. Okay, so that's just quick overview. Go ahead and check out the Jupyter Notebook if you want to see the code yourself. Okay, thanks everyone.